Welcome back. We were discussing systems of linear inequalities, and we already talked about what it means to have a solution. It's where the shaded areas of two linear inequalities overlap. We had our first example, which did not overlap, so there's no solution. So let's go ahead and work on the next example, and hopefully we have some overlap. So the first thing we need to do is we need to graph these two inequalities. So let's start with the light blue one. That one's going to be easier. It already has y isolated by itself, so it should make it very easy to identify the slope and the y-intercept. So we have the slope here. The slope is 2, but we are going to start with the y-intercept, which is -3. So let's go ahead and do that. -3 is right here, and we're going to use our slope up 2 over 1 and plot some points. I messed that one up already. Up 2 over 1, up 2 over 1. Okay, don't be afraid to go in reverse. And there we go. Now, we need to determine if it is a solid or a dotted line. That is discovered by looking at the inequality. If it has a line underneath it, it's solid like the line. If it doesn't, then it's going to be dotted or dashed, whatever you prefer. So I'm going to do dash just because it's a little bit easier to draw. So I'm going to draw my line, arrows on both ends, get my trusty eraser, and dash, 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 dash. And just like that. I'm going to add a few more just so you can really tell that it is a dotted line. Now, what this dotted line shows is that the points along these lines are not solutions, okay? So that's very important that you make the distinction if it's solid or dotted. Now, let's work on the next one. Notice how the y is not by itself, so we need to solve for that y, which really isn't that hard in this case because y does not have a coefficient greater than 1. So we're just going to subtract 2x from both sides. We get, I was using the wrong color, y is greater than 2 minus 2x. We should be able to identify our slope here. Our slope is -2. Our y-intercept is +2. So we're going to start with our y-intercept. So our y-intercept is +2 right here. And we're going to use our slope to find other points. So we're going to go down 2 over 1, down 2 over 1. Down 2 over 1, down 2 over 1. And I can go in reverse if I want, okay, by going the opposite direction. Now I need to determine, is this a dotted or is it a solid line? It has no line underneath it, so it is not solid. So I'm going to make this another dotted line. Let's connect the dots. Decent job. Try to go all the way across your graph if possible. I was a little short. I'm going to make this a little bit thicker so it's easier to do the dashed. Oh yeah, this is much better. Now we're cooking. Okay, got my dash line. There we go. Now, one thing I forgot to do with both is I forgot to shade, so make sure we can do that now. So with the first one, because its y is less than, we are going to shade below the line. Shade below. Okay, so let me get my shader out. Now, some people struggle with what is below the line, especially when the lines get really steep. So you just choose any point on the line, and you think, where is below that point? Well, obviously below that point is here. Choose another place on the line. Right there, there's a point. Where is below? It's right here. And then you're just going to shade everything in that region. Okay, can't cross the line. Kind of like drawing, okay? You want to stay inside the lines. There we go. Okay, there's our first one. Now let's take a look at our second graph. As you can see, it's y is greater than. If it's y is greater than, it is shade above. So let me get my pink shader or magenta, whatever you call this color, and I'm going to shade above this line. Now, I'm not concerned with the blue at all. I'm just minding my own business. I'm going to shade above this line no matter what, okay? So don't worry about the blue. We'll handle that business in a second, okay? Just pretend that it's not even there and shade your second inequality. Okay, so now we're done with step 2. The third step is to recognize where is the overlap. This is especially useful if you use highlighters, different color highlighters, if you use colored pencils, crayons, something with different color distinctions. But as you can see here, using notability, it's also pretty helpful. You can see where it changes color. Where it changes color is the solution. Now, keep in mind the solution does not include the lines or the points on the lines, but it's all in this area. Okay, so this triangular section right here is the solution set. So that's, you have to graph solutions for inequalities. Otherwise, if you try to list all the solutions, it's an infinite list. So you have to graph them. That's why graphing is useful. Okay. Now, if you are constrained to pencil and paper, I will give a suggestion. If you draw your lines, let me go ahead and draw just a quick example. Let's say you're using your pencil, and here's your first one. Maybe shade your first one using vertical lines like this, and then when you draw your second line, draw like horizontal lines for your second one, and then anywhere where you see a cross section, like in this area, that's going to be your solution. Okay, so that's another way to do it on pencil and paper if that is your medium. So let's go ahead and look at the next example. What system of inequalities is expressed in the graph below? So we have a system here, and we see that we have a solution. Okay, so we have a pink region, we have a blue region, and they intersect. Okay, notice that one line is dotted, one is solid. So let's go ahead and just pick one to start with, and then we'll go from there. So I'm going to pick the blue line, and the first thing I need to do is find the equation of the lines. Let's go ahead and I'm going to write that out for steps. Step 1, we are going to find line equations. For finding the equation of the line, you imagine that the inequality is not there. The line itself is always, you can always write in the form of y equals mx plus b, where b is your y-intercept and m is your slope. So if we're looking at this light blue line, we are going to notice that the blue line has a y-intercept of -2, and our slope is up 2 and over 3. I'm looking for intersection points, so I notice that obviously the y-intercept is -2, and it goes up 2 and over 3 to the next intersection. So up 2 over 3x. Now, I can't keep the equal sign because these are inequalities that we're talking about, so I need to change it to the inequality. Well, check to see if it's graphed above or below, or shaded above or below. So determine inequality. So if it's graphed above, in this case, graphed, or shaded, sorry, I keep saying graphed. So if it's shaded above, it's going to be y is greater than, and if it's shaded below, then it's going to be y is less than. Okay, in this case, it's shaded above, but that's not all. Notice how the line is solid. If the line is solid, that means we need to have an equal sign. So solid versus dotted. Solid, we have this, and then dotted, we have these inequalities. Okay. So I'm done with one inequality. Now I need to get the other one going. So my other inequality, let's find the equation of the line. So it looks like the y-intercept is at 4. So I have y equals 4, and then my slope, let's see, there's 1 point, and then I'm going to look for the other point here. It looks like it intersects right about there. So that's down 1, 2 over 1, 2, 3, 4, 5, 6. So I went down 2, that's -2 over 6x plus 4. I'm going to simplify that. Y equals -1/3 x plus 4. Now I need to determine which way it's shaded. Is it a dotted line? It is a dotted line, so I know I'm going to be using, because it's a less than sign, no less than or equal to. And I know it's shaded below, so I know it's going to be less than. So it's y is less than -1/3 x plus 4. So there you have it. There is my system of inequalities that leads to this graph. And that's how you kind of go in reverse. It's basically a two-step process, and there you go.